Today we're delving into a story that really made waves back in 2025. We're talking about Matthew Paz. He secured first place in the Regeneron Science Talent Search. That's, widely seen as the top science competition for U.S. high school seniors.
It really is. And his research is fascinating, blending math, astronomy, AI.
Right, and it even got published in the Astronomical Journal. Pretty impressive stuff.
Absolutely. But what's just as remarkable, maybe even more so when you dig into the material we looked at, is the speed, the sheer speed of his journey.
Okay, tell me more about that.
Well, the analysis points to him completing AP Calculus BC in 8th grade.
8th grade, wow.
Yeah, I mean, that's a serious college-level calculus course. Most students, if they take it, they're aiming for maybe 11th grade, junior year.
So that timeline, it's not just inspiring, it's instructive, as you said.
Exactly. It tells us something important.
And that's really why we're diving deep today. Matthew's path, based on what our sources show, it's like a potential roadmap. It highlights what's possible, but maybe more importantly, what's becoming, well, necessary.
Necessary is the right word.
Yeah.
In this age of AI, I mean, it's reshaping everything so quickly. And
Right.
the research we reviewed makes a really strong case that accelerated learning, specifically in math, isn't just a nice to have anymore.
It's foundational.
Precisely. Foundational. So our mission here is to unpack that, to pull out the key insights from the material for you, our listener, and sort of map out this this changing math landscape.
And it's interesting how deep that connection goes, right? Between AI and these, sometimes abstract seeming math fields.
Oh, absolutely. Think about it. Every time AI recognizes a face in a photo or tries to predict where a stock might go.
Or guides a self-driving car.
Exactly. Underneath all that, very often, are complex optimization algorithms. And those are really rooted in calculus and linear algebra. These AI systems, they're constantly learning, constantly adjusting based on massive amounts of data. And doing that efficiently, it really demands a solid grasp of these core mathematical ideas.
Which brings us, naturally, to the big question.
Yeah.
How are our schools doing? Are they preparing students for this future, the one driven by AI?
Well, the sources we looked at paint let's say, a challenging picture.
All right.
The assessment seems to be that many school systems are kind of stuck teaching math for a world that looks more like the 1990s.
Calculus in 11th grade as the standard.
Right.
Olympiad math sort of tucked away as this niche extracurricular.
Right. And the material mentions that gifted students, the ones ready to move faster, are often told to just wait for the standard curriculum.
It does feel a bit like preparing for yesterday's world, doesn't it?
It does. Like the world has already moved on and the preparation hasn't quite caught up.
So this leads to a really practical point for parents listening. What can they do in this kind of environment?
Yeah. And the sources are actually quite encouraging on this front. They're very clear. You don't have to be a math whiz yourself.
You don't need a PhD in math to guide your child.
Exactly. Look at Matthew Paz again. His success wasn't just random. It seems rooted in someone believing he could handle advanced concepts early. Someone asking that fundamental question, why wait? Why not now?
That mindset seems key.
It seems crucial. That belief, combined with finding the right guidance and resources, that appears to be the pathway.
Reading through the materials, it struck me that this isn't just about efficiency, about keeping pace. There's maybe a deeper developmental aspect, too.
Yes, that's a really important layer. The sources touch on this idea that the brain's pathways for mathematical thinking, for abstract reasoning, they're most flexible, most adaptable in the earlier years.
Like building the foundation when the concrete is still wet, so to speak.
Kind of, yeah. So delaying exposure isn't just slower. It could mean missing a critical window to really develop that intuitive math brain wiring, the kind of wiring that's going to be essential for these future AI-heavy fields.
Which really ups the stakes for starting early, doesn't it?
It makes the case pretty compelling, I think.
Now, the sources also talked about combining the best of both worlds, technology and human expertise.
Right. It's not an either situation. It's about fusion. The materials describe how some organizations are doing this really effectively by bringing in people who've actually competed and succeeded at the very highest levels.
Like medalists from the International Mathematical Olympiad, the IMO.
Exactly. Gold medalists, silver medalists, people who have lived and breathed elite-level mathematics.
So what is it that these human mentors, these champions, bring to the table that, say, an AI tutor just can't? The sources seem to break it down.
They did. 3 key things really stood out. First, inspiration, pure human inspiration.
Okay.
An AI can give you facts, it can analyze data, maybe even write some text, but it can't give a student that feeling, that visceral sense of possibility you get when you meet someone who actually stood on that IMO podium with a gold medal.
When you see living proof that it's achievable?
Precisely. When someone who has walked that path solves a problem you thought was impossible right in front of you. Suddenly, excellence isn't just some abstract idea, it becomes a tangible goal. Matthew Paz's story wasn't just about learning formulas, it was also about someone believing in him, inspiring him.
That makes sense. What was the second element?
Strategic insight. Real-world strategic insight.
Meaning?
Well, AI can crunch data, suggest learning paths based on algorithms. But these medalists, they know the terrain of high-stakes problem-solving from the inside out.
They've been in the trenches.
Exactly. They faced that intense pressure of international competition. They've learned how to think clearly under stress, how to spot shortcuts, how to decide which problem to tackle first, or even when to just switch gears entirely.
That kind of battle wisdom.
Yeah, that lived experience earned through struggle and success. You just can't program that into an algorithm.
Okay, inspiration, strategy, and the third.
This one might be the most crucial, actually. It's mentorship and mindset development.
The human side of learning.
Completely. Elite mentors, the sources suggest, model resilience. They encourage genuine curiosity, not just answer getting. They foster humility.
And they share their own struggles.
Yes. That's huge. They share personal stories, times they failed, the messy process of revision, those incredible aha moments after hitting a wall. AI can't simulate that vulnerability, that shared journey.
There was that anecdote in the sources.
Right, about the student ready to give up after a tough problem set.
Right.
And the mentor shared how they also failed countless times before their own breakthrough. That kind of honesty, seeing the process behind mastery, not just the polished result, it's invaluable for students hitting those inevitable roadblocks or doubting themselves.
Absolutely crucial.